Hey guys, I think my audio has now finally fixed and using AirPods was the issue. So now since I'm recording on the computer, it might record a lot better. Before my sound was so like murky. All right, so let's get back on track with the multiple choice sections. This is the last part of multiple choice finally. And we're starting from question 85. So the question 85 says the graph of f prime, the derivative is shown, the function f has a local maximum. Local maximum means I need to look for, or min, where f prime of x is 0. This is a graph f prime. So where is it 0? It's here and here. And to find out maximum, you want to think of like a curve that looks like a parabola but upside down. In the beginning, the slope of that is positive. It hits 0, then it slowly turns out to be a negative slope. So what you want to find out is your derivative is positive, then your derivative goes to negative here. What you will notice is that for this one, your derivative up here, all the values from this to that end is positive, then it goes down here, which is in the negative section, right? Like all of this is below x and all of this is above x. So there we go. So you go from positive to negative. So the answer has to be positive 1. That's where the maximum is going to occur. Vice versa, just for just understanding this is in the negative section, and this is now going in the positive. If you're going down, then you're slowly going up. This actually represents minimum. So like I said, the derivative of f of x, which makes it 0, it always represents max, min, or which we call them critical points. Please remember that. Super, super important stuff. 86, the f prime of x is greater than 0. So that means that means it has to be increasing overall. Your slope is positive. And the derivative, the nth derivative of the f of t is going to give you a 0 for this one. And you're taking basically the area under the curve, if you will. Which of the following could be a table of values for the function f? Now, because we know this, we can eliminate at least a couple of choices. For example, this one. You increase from -4 to 6, but then you decrease from 6 to 3. Remember, it's got to be increasing all the way throughout this graph because it says f prime of x is greater than 0, positive slope for all real numbers. So C is not true, D is not true either because look, you're staying stagnant at 0. You're not increasing. It's got to be positive slope. And this one here is also positive. So, okay, there we go. So we're really down to A, B, and E here. Now, when they say that the antiderivative of this entire thing is 0, so suppose, let's say that I give you like a curve, right? And you're trying to find the area under this curve. If that ends up being a 0, there's gotta be certain values in which like it gives you like a negative portion and it balances out with the positive section. So like when you add them up, it actually gives you a 0. So what this is telling you is that you gotta have a negative value as well as positive values all intact together. So this is why A is not gonna be an answer because you have all values that's negative, which means if you were to take the antiderivative of ft dt for this particular function, you will get like a negative number for that. Like, I don't know, like -10, -20 or whatsoever. So that's why A is not gonna be true. You have B and then you have E. But E is the same reason. If you take the integration of f of t for this particular set of set of data, like you can draw it too, 4, 5, 7, and all the value is positive, right? So your area under the curve will be positive and it will turn out to be greater than 0. Only when you have a good balance of both negative numbers as well as positive numbers, it will even things out and get you a antiderivative, the area under the curve to be 0. All right, 87. The graph of f double prime, acceleration graph, second derivatives, is shown for -2 to +4. What are all the intervals in which the graph of the function is concave down? Okay, concave down means, again, we're looking for the values in which it's the second derivative is negative, right? So that's when it's between -2 and -1 and between 1 and 3. So that's simple. It's just going to be E. That's probably like one of the easiest question here. Then it slowly starts to get a little bit challenging. This what is it? The light question, the land question, the street light. A person whose height is 6 feet is walking away from the base of the street light along a straight path at a rate of 4 feet per second. So we say that the moving away from the street lamp is about 4 feet per second. If the height of the street light is 15, what is the rate in which this person's shadow is lengthening? Now, when you first take a look at this question, you must first understand that this is a geometry question more so than anything. If I were to draw like this, like a line straight from wherever the end tip of the shadow is, all the way down to the highest point in the lamp or the street lamp, this will create what we call similar triangles. And similar triangles always works in terms of ratios. What we're looking for is something called a change in the shadow, which is this. That's how much the shadow is going to increase or decrease. Let's say that I call this change in S over change in time, S for shadow, right? So we don't know how fast the shadow is really changing. We really have no idea. But what we do know is that the height is staying stagnant and the lamp height is also staying stagnant. And the rate in which the person is moving away from the lamp is also stagnant. This is a ratio question. And here's how you set up the ratio. Let the height over length be consistent for this triangle that you see, which is right here. And there's another triangle that you can draw with the lamp like this. Those two triangles must be equivalent in terms of ratio when we're talking about height over length. So the height over length for the person will be 6 over ds dt. I'm just gonna call this S prime for derivative of shadow. Then the height over length of the larger blue triangle will be 15, that's the height, but the length will be changed in such a way that it's 4, because that's how fast the person is moving away from the lamppost, plus the rate in which the shadow is lengthening. That will give you the overall distance when you're doing that way. So what do? You pretty much simply set these two ratios up together. 6 over S prime is equal to 15 over 4 plus S prime. Or, I mean, you can just kind of call this X, if you will, because I think that will make it a lot easier. And you see a fraction equals to a fraction, what do? You just simply have to set up a ratio and cross multiply them, right? So 6 times 4 plus X equals 15 times X. 24 plus 6x equals 15x. You subtract x, 6x on both sides of the equation. So 24 equals 9x. Divide by 9 on the other side, you get x equals 24 over 9. This will be feet over second because we are talking about the rate in which the shadow is changing over time. So 24 over 9, if you type that into your calculator real quick, I'm just going to use this. You get 2.667 feet per second here. So that is going to be the answer, and the answer choice is going to be B. Okay, so this is like a ratio question. All right, 89. A particle moves along a line so that its acceleration is given. If the particle's velocity at t is equal to 0 is 5, then what is the velocity of the particle at t is equal to 3? All right, so if I want to find out the velocity, we want to use the and I'm given acceleration, I need to integrate acceleration because integrating acceleration will give me velocity. Okay. All right, so let's find out what the velocity is at t is equal to 3. See, the time is accumulated over time. From time is greater than or equal to 0 all the way down to t is equal to 3. We want to integrate this in terms of time and say, okay, we want to go from 0 to 3. Acceleration in function of time, if we integrate that in terms of t, we'll be able to find out just how much total velocity has been traveled, or what the velocity was within that span of time. Okay. All right. So we're going to go to our calculator here. And we are going to find out what the velocity is by going to math, function into antiderivative of 0 to 3. So we are simply going to type this up. The function here says x plus 3 divided by, please make sure you use the parentheses for everything, x to the power of 3 plus 1. So you can call the t as x, it doesn't really matter, and call this x. And you'll find out that velocity of the entire thing equals 6.71. And using that as our answer, oh, that's my fault. Sorry, that just keeps on changing on me. Okay, so the acceleration, and you take the antiderivative of it from 0 to 3, you find out that that's 6.710. But remember that the velocity at time is equal to 0 was already 5, so we want to incorporate that along with it. So plus 5, 11.710. So the final answer should be E for this one. Okay. All right, question 90. Now, 90 is probably one of those questions I actually did not do so well, but for every single one of these, like you pretty much kind of want to change it. Like you want to take this actual function and you want to see for yourself as to like what exactly is happening. So we have function of 2x dx and the derivative, antiderivative of 6 to from 6 to 12, and that actually gives you 10. And you're trying to find out which one is equivalent in terms of t now, right? All right, so let's say that you're trying to find out t as 2x because whatever's inside the parentheses, you want to set them equal to each other. Okay. That would mean that if I were to take the derivative of t, like so for example, let's say I want to find out dt. dt would actually end up being 2, right? Because that if I were to find out the derivative in terms of like x here, the derivative of t will be 2 times dx, because that's what you would get if you were to take the derivative of it. So now with that in mind, so how would I be able to replace dx then? Well, I have to divide both sides by 2 and get rid of the 2 there. So I get dx is equal to 1/2 times dt actually. So I use this to plug in for dx here. Okay, and what you will get is that f of t, because I replaced t with 2x and times dt, but the 1/2 will actually come along with it as a result. And you're integrating from 6 to 12, but these two also must change. Why? Because t is 2x. Okay, that would mean x is equivalent to saying t value, but you have to divide that by 2, you see. Okay. Or actually better yet, we don't really have to do this. You can just kind of like plug in x as already given to us as 6 and 12, your max and min values, plug it into the t value, which is 2x, and get the low and high values for t. So t max is 2 times the highest possible value for x. T min is the 2 times the lowest possible value for x, which is 6 and 12 plugged in respectively. 24 and 12 are the values in which you're going to place right there, which means I eliminate all the other choices that is not going to give me that solution. Okay, so then at the end, this entire thing ends up equaling 10 here. Okay, because that we replaced everything and then we got that equal to 10, right? Now, the only difference between this answer that I have and with the answers that was given to me is that this 1/2 is gone. The 1/2, remember, it's a constant value, okay, in which I can simply kind of take it out in front of the whole thing like this. If I were to integrate this versus the other one that I just written down with the 1/2 inside being the integration, it doesn't make any difference. So how do we get rid of this 1/2 to the other side? By multiplying it by 2, which gives me 20 for my final answer. So the answer has to be B. Okay, so this was just like playing around with the variables. So it gets a little bit tricky, but that's what you need to do. Set the t as equal to 2x, set whatever's inside the parentheses equal to one another. That was the first start. That's the beginning stage of how to do these problems here. All right, 2 more questions to go. 91, let f be a polynomial function with the values of f prime of x at the selected values. So which of the following must be true from -2 to +6? Okay, so it seems like the derivative tends to kind of decrease here. Then it increase, again increase, then it decreases again. So the graph of f is concave up all the way. Nope, because there's certainly ones that decreases, which makes it concave down. The graph of f has at least 2 points of inflection, it says. Now this is crucial. your derivatives, as you can see, it decreases, then it increases from 2 to 3. Negative 2 to 3. You can see the values for themselves and to come up with the same conclusion. If you have the change in the derivatives from being negative to positive, okay? So basically, the point of inflection is when f double prime becomes 0. The change in the derivatives becomes 0. So somewhere along this line, when you go from decreasing to increasing, it means that you slowly start to kind of go down like this. Then you hit the lowest possible point, and then you go back up. Means you have to hit a 0 at some point for the change, right? I am not talking about the actual values between these two. I'm talking about the changes between these two values. So it's very important that you understand that somewhere along the lines of between decreasing to increasing, you gotta stop before you can change its velocity. So here again, you still go to increasing, but then that's like when you increase, then you slowly start to kind of like stop, and then you slowly start to decrease because you go from 7 to 5. That means you're decreasing. Think of a roller coaster. When you go up the king to ka, you are actually increasing, and then when you actually hit the highest point, there's an instantaneous slightest bit of a second that you're actually not moving. Like you're not speeding up, you're not speeding down, you're stagnant. Then you slowly start to experience the drop, right? Slowly, and then like it's gonna be rapid afterwards. So when you go up and then when you go down in terms of your velocity, wherever your velocity actually tends to be a 0, that's called point of inflection. It means your change in the speed becomes 0. So that means the graph of f has at least 2 points of inflection. Well, there we go. The point of inflection happens when the velocity changes from being positive to negative, or from negative to positive. There's that one instance right here, and there's another instance right there. So these two will be the location in which those things will happen. F is increasing, certainly not, and we can certainly see where it's decreasing. F has no critical points. That's this one here. We are trying to find out which the following is must be true. Who knows? There could be a point where it will reach up to 0. Critical points, remember, is when f prime of x is equal to 0, even though it's not listed. I don't know, maybe somewhere between these two x values, there could be a 0. You never know. F has at least 2 relative extrema. Now, for this one, it says at least 2 relative extrema. Extrema means either max or min values. Now, from what I can see, there could be zeros in multiple different locations. Like, it could be decreasing, and then, it could hit the zeros like maybe multiple times before it actually goes back up to 1. So what I'm trying to say here is that your extrema, your maximum values within this given table is not always restricted to having 2. And it says at least 2. Who's to say that I'm going to have, 1 relative extrema? I don't know when this f prime of x is going to happen at 0. Where is it going to happen? It could happen between this, could happen between that, or it may not happen at all. It's really not, there's not enough information for us to make that conclusion. But based on how it's changing, it's decreasing to increasing. Between those two, there's gotta be a point of inflection. So this is a must situation. So the answer here that's left over is just gonna be B. This is just testing you to see whether you understand second derivative test, point of inflection, and all that good stuff here. Okay. All right, last question, number 92. It says, let R be the region in the first quadrant bounded below by the graph of y equals x squared. At this point, you guys should all know what that graph looks like, right? It looks like this. And above the graph, y equals square root of x. So square root of x actually looks like this, okay? And R be the base of the solid whose cross sections are perpendicular to the x-axis that are squares. Okay, what in the world is this talking about? First of all, when you graph these two functions, you guys are supposed to get something like this. And we're gonna call this region called R here, okay? What is the volume of the solid, it says? So here's what you must remember. If you wanna find out the area under that curve, under this region, you always must do top curve minus the bottom curve. What that means, you're taking the square root of x, because this top curve here is represented as square root of x. This bottom curve here is represented as x squared. So you're gonna do that, okay? And every single these distances between the top curve and the bottom curve, imagine for a second, okay, I flatten this out, flatten this R curve out, whatever this distance is, I replicate that height and make a little square out of this. I take this distance and then I take another square out of that, and then I take that area. And then you can do this, for multiple squares, and you're going to keep on doing this again and again and again and again. This is the volume of the figure that you kind of want to visualize for yourself. So if this is one length of the side of the square, right? I'm flattening this out, and this length right here is equivalent to that. The square, this other height in which I want to find out the area for, you actually get the same exact length as the base of this square. And when you basically integrate this, you integrate that area function. If you integrate an area, it actually gives you volume. That's the power of integration, right? If you integrate a curve, it gives you the area. That's a couple of things that you just kind of want to memorize for yourself. All right, so how do I find the area of the square? You just have to take that and square it, right? That is a function that you want to use, integrating that. And you want to find out this is a definitive integral, or definite integral, from start to finish. So where does this curve start and where does this curve end in terms of x? That's the variable we want to use. So it definitely kind of starts at 0, but then where is this other intersection point that they're going to meet up at? So when x squared is equal to square root of x, that's basically what you want to solve for, okay? The easiest way to do this is, if you plug in x equals 0, you can kind of see like they both give you 0. Another great answer you can use is actually just 1. You just kind of plug in 1 and see for yourself that this actually does make sense. Or you can use your graphing calculator. So I'm just going to do that here. So if I just go to y is equal to, let's say x squared, clear all this x squared and then square root of x. And I'm going to change my window setting so it's from 0 to 1. Because I want to only focus on, my y values, I'm sorry. So y values has to be from negative, 5 to 5. My y values are still way too big. I'm going to change this to -1 to +1, guys, just to kind of give you a better example. So there we go. There's your region R. And you can see how they both actually meet up, the red line and the blue line. Here is at +1, here is at 0. So you're integrating this area from 0 to 1, basically. All right, so let's see what I am going to get if I do that. 0 to 1. And I'm going to plug this in by using the calculator. Push it on here. All right, so then you guys all know where to go for the integration. Go to math, go to 9, from 0 to 1, square root of x minus x squared. But I think I forgot that there's got to be, I'm going to second delete and insert a parentheses. Nope, that's not it. Parentheses. And you want to raise this whole thing to the power of 2, because it's this whole thing raised to the power of 2. Please don't forget that you gotta have to put a lot of parentheses in for the calculator to not lose track of what you're trying to square. And then when you press enter with that, you get 0.128. Let's see if I get the same answer. Yes, there we go. So the answer here is just going to be A. Okay, so utilize your calculator. This is a calculator section for crying out loud. So that's all the correct answers for the 2012 AP Calc exam AB. Hope this helped. Make sure that you kind of try a lot of practice questions like these. Most cases you'll see similar questions, if not the exact same questions. Well, most likely not, but very similar questions to these. I hope this helped, and on the next video we'll finally go over free response questions. And yeah, that's it.